your host Geetika Mishra, and you're welcome to this very special series, Innovation for Change by Shiv Nadar Foundation. In this series, we embark on a thrilling journey of innovation with the most promising young minds of Shiv Nadar schools, who share their insights about the exciting possibilities of the future. For example, the vastness of space holds endless possibilities as humanity remains unaware of its immensity. What if we could unlock the untapped potential of space to power our planet? Imagine a world where we no longer rely on traditional sources of energy but instead utilize the boundless resources of space. While wind power, hydroelectricity, solar, geothermal, these are all potential alternatives. But what if we considered extracting energy from space solar farms? Should we explore the possibilities and usher in a new era of sustainable energy? Let's find out the answers today with the students of Shiv Nadar School, Noida. Joining me here today are Sara Garg, Shaurya Bhartiya and Nishtha Sehgal. Welcome guys. How are you all doing?
Thank you, ma'am. It's great to be here today.
How are you guys doing today? Tell me a little bit about yourselves.
So my name is Nishtha Sehgal. I'm an international baccalaureate student at Shiv Nadar School, Noida. I am a visual thinker, a science enthusiast and an avid reader.
Okay, what about you, Shaurya? Are you an average reader too?
I used to be really into reading, but now being a graduating 12th grade student, my focus has shifted a lot more onto studies. And I'm also looking to be an avid scientist in the future, looking at problems of environment and space specifically, which is why I'm so excited to be here talking about this topic today.
Okay. What about you, Sara?
I'm in grade 8 right now, and I have a keen interest towards reading as well, and I'm passionate about STEM and science. I like researching about particle physics, and I'm excited to talk about this topic.
Wow, particle physics. Okay, since all of you are so interested in science, Shaurya, why don't you begin by telling me what is a space solar farm?
So a space solar farm is a new idea for energy that has honestly come from decades of sci-fi movies, straight out of movies like Men in Black, but now we're looking to implement it in real life. And what the concept basically is the idea of a set of solar panels in space that can harvest energy directly from the sun, which is the biggest energy source we have around us, and beam down this energy through radio signals or perhaps even infrared lasers down to receivers on Earth, so we can harvest this energy directly from space of the sun. And this energy form is actually found out to be quite efficient, highly efficient even. And if we can implement it properly, then it'll change the scale of sustainability for cities on a huge scale.
Okay, just like your friend mentioned that sun is, of course, it has limitless energy. But if this thing is so potential, I mean, if it has endless possibilities, and we have so many energy problems, if this thing happens, won't all our energy problems end once and for all? What do you have to say about this? What are the challenges out there to, build space solar farms?
So I do believe that if this is implemented at a larger scale, it can, the amount of energy that we can harvest out of the sun by being in space is huge and can power millions of homes and reduce our dependency from fossil fuels, which are actually not good for environment. But obviously every good solution has its set of problems. For this one, the biggest problem is the cost. The costs are through the roofs and we can't afford to invest in something like this at this stage. Adding to that, the environmental hazards in the space, they are huge, like solar debris and intense solar radiations, which can degrade the solar panels much faster than actually on Earth. So, and also transmitting the solar radiations that are captured from space back to Earth in microbeams, it's very hard, and we're not at this state of technology right now. So, but with more research, we can maybe reach there.
Okay, so is there any existing research, which is happening in this field, or do we have any sort of achievement any possibility that, okay, this is not just in theory but also in practice, that someone is actually working on it? Is there any experiment out there?
I think the recent emergence of reusable spacecraft by companies such as SpaceX gives us a huge opportunity and is a big step towards launching space solar farms.
If I may add, then I'd like to point out that very often the biggest challenge that comes with such massive scale scientific endeavors that we haven't done before is that it's easier said than done. And theory can only take you so far, and while we've had researchers working for a long time on the concept of harvesting energy directly from the sun, the implementation has a lot of complications, as Sarah talked about earlier, and there's a million different ways to approach it. So that becomes the biggest challenge, especially when us students of science, it becomes easy for us to see the significance of this issue and to see the solution and to think that this is the best course of action. But for the larger people in power, policymakers, the public opinion, it becomes difficult for them to take their eyes away from all the problems and all the things we're working on here on Earth and so it becomes difficult for us to expect funds from them and the support from them towards space, where if they don't even understand the issue and the potential solution, how can they support it and how can they fund such a massive project?
Very true. I am glad you mentioned this because, I also wanted to ask you this. India was very late to the space party, if I may say. Other countries were far ahead from us when they began their space programs and their space missions. But recently, if we go into the past and we look back, India has had absolutely remarkable feats when it comes to the space, because we literally landed on the side of the moon where the sun doesn't shine, and no country has been there before. So do you think, and of course our government and our policymakers are also pushing towards space technology, and every day we hear about ISRO's new mission, solar mission, lunar mission, this, that. So do you think India as a country, India as a nation is ready to probably venture in something like a space solar farm much earlier than, say, maybe a SpaceX or maybe the United States or UK or other developed countries of the world?
So India currently ranks 4th globally for solar power capacity, and recently, in fact even last year, the solar power capacity increased from 21,000 megawatts to 70,000 megawatts, which is a huge transition. I think with India's advancements in green energy and space sector, it's a great opportunity for India to start looking into space solar powers.
Okay. Would you like to add something?
If I may add, I would like to say that India does have the capacity to do it, like Nishtha mentioned. We have the bright minds to do it, but the costing still remains a problem in India. We don't have enough funds to create such a big project. The two leaders for this project are China and UK, and they've started investing in such a things and have projected to launch their solar farm by 2028. But if as a nation in India we contribute towards more greener fuels and better alternatives, I think we can create an impact and we can try to launch a space solar farm as well.
Okay, yeah, sure.
I think that while this step, as Sarah said, is quite a difficult one for India to make, especially being that out of all the countries that have gone into space, India is on the relatively lower end of its development, and still we've managed to make it to space. So I think even though this step is difficult, it's a necessary one that will give our nation the boost and the edge that it may need to become a true competitor in the scene of space. And so I think the best way to achieve that right now would be for India to try and join the collaborative efforts, because a project like this needs international collaboration from countries all over the world. We're not looking at something on just national scales anymore, but this will change every country's energy as a whole.
True, this is something that could really use, solid international cooperation. But because all of you all have in some way mentioned that cost is a very big challenge in developing space solar farms. So I also want to understand a little bit about cost once we are there, right? say for example we have a space solar farm and we have electricity coming from it, we can harness electricity from those farms, then how are we going to make this thing commercial? You know, like I'm sure it's not going to be free for all of us to you know, turn on the switches in our homes. So what's the commercial aspect of it? Once we get there, you know, is there any discussion about this, since Sarah just mentioned that China and UK are ready to come up with the first space solar farm in 2028. Once they do it, what next? I mean, what's the commercial aspect of it?
So the plan of a space solar farm is a very hyper-competitive one, because it not only brings in the space race that so many countries and companies are competing for, but also the energy race. So then these are two goals that so many nations and world leaders are chasing. So I think that whoever gets there first, the only logical step would be to try and monopolize this energy source until others catch up. But I think once all countries have developed the technology to reach this point, the main issue in commercialization would be that such funds cannot, of course, be procured by private companies. So it has to be government run or by something like SpaceX and NASA. So private companies will definitely not get their individual ownership of this until way down the line. And a big concern that I personally have is also for the underdeveloped countries that aren't even involved in the space race yet. And the fact that if the developed countries get such a boost in their energy, then what will happen to the underdeveloped countries? And there's a chance that they may get left behind, and there may be a big power disparity because of this. So I think that's definitely a concern that will have to be kept in mind.
That's very true, of course, because countries who are not even in the space race yet, they will definitely be the one, you know, below the ladder. Okay guys, enough of space solar farms. Tell me, what is your school doing about, you know, space solar farms? Because you all have, I think this is a shared interest, three of you have on this topic. So do you have some existing clubs or, you know, some sort of existing research at Shiv Nadar which has, you know, boosted your interest so much, because you all know so much about it?
So Shiv Nadar School's approach to space solar farms or any field in science involves an interdisciplinary research. So an example of that is our most recent endeavor is Project Urja, which is a round square initiative hosted by Shiv Nadar School, Noida. It was a collaborative effort of 6 schools across the globe where we came together and created clean energy sources or prototypes that can help power our school, right? So our aim was not only, it was to give students a hands-on experience as well as raise environmental awareness. So we created several posters, we hosted fundraisers, we conducted sessions, we showed people, it was inspired by the movie The Boy Who Harnessed the Wind, and so we showed that in our class, and it was an amazing opportunity for students to explore the field of clean energy.
That's really fun. And Shaurya, I think you're writing your boards this year.
Yes.
So eventually you're going to venture in college, and, you know, you are going to enter college, and are you going to take up something related to space in college?
Yeah, so my plans for college are to go into 2 major fields, and one of those is space sciences. That would be aerospace engineering or astronomy or astrophysics, and the other is environmental science engineering. And solar space farms becomes the perfect interdisciplinary blend crossroads for both of these fields. So I definitely see myself working on this concept more in the future. In fact, my interest in both of these fields came so much from my experience in school, because our school, as Nishtha said, it takes a very holistic approach to science. But a part that we also focus on that's very often missed is the integration of this science into society. And what's important for that is the integration of the arts and the integration of humanities and those subjects to bring the knowledge and the theory from science into the real world, and as you said, to commercialize it better. And I learned this in a project that I worked on called ARSSDC, which is a very interesting project for me in the 10th grade, where we basically, along with a set of I think 30 to 40 students from a bunch of schools, we collaborated to create the design of a space settlement in the future from scratch. And these solar space farms were a big part of that idea, and that's where I heard about them for the first time.
That's lovely. So many schools especially coming together, 30 to 40 schools coming together for a sustainable program is actually incredible. I don't think these things happened when I was in school. Okay, you're the youngest one of all, Sarah. What plans do you have, and how has your experience been in your school working into all things science?
So I always had a keen interest in science, especially since my brother Naman, he actually helped me develop this interest, and I used to talk to him about all these kind of stuff, and it really helped me understand about it and delve deeper into it. Then I even collaborated with a lot of teachers in my school, a lot of my seniors, and they really helped me to understand its importance and, as they said, to integrate it in our society. And since I've done a lot of these projects in our school, like the physics conclave, the science competition and the science fair, all of these helped me understand the role of science in environment, and that has really intrigued me to pursue that as well. In 9th, I'm going to go into IGCSE, and over there are a lot of projects that you have to come up with. So I think this is one of the approach that I'll be following and taking myself to high school with.
That's lovely. What's IGCSE again?
So IGCSE is a different board that our school offers from 9th to 10th. It's a Cambridge board, and it doesn't have your conventional exams. It does have exams, but it has a very different approach towards them.
Okay, this part is a little new to me because I was a regular CBSE kid, 9th, 10th, 11th, 12th, I mean right from first grade. So can you all tell me which boards you all belong to? You are right now in CBSE?
Right now in CBSE, but in 9th I'll go to IGCSE.
Okay, and what about you?
I'm the same as you. I'm a CBSE kid at heart.
So I did CBSE till grade 10, and after my boards I switched to IB. I am planning to pursue designing, product or industrial designing to be specific, and IB really gives me the opportunity to merge subjects of my interest so that I'm better suited for college, or so I'm better suited for college when I go there.
Okay. Guys, it's lovely to see how you all understand the crossroads of various disciplines. I mean, as you mentioned, in interdisciplinary studies, not everyone understands that yes, something like environment and science can be merged. Something like space and policy can be merged, because these days we have technology policy, we have space policy, and so many things. So it's lovely to see that. I mean, honestly. Do you all want to sort of throw a little light about space solar farms a little more, and tell me, because she mentioned that the first space solar farm is already being developed by China and UK, right? So is this a government funded program, or are the private companies working on it? Like, do you have a little knowledge about it?
So I'm not quite really sure about it, but I know a little bit about China. So it was the first one who came up with the idea to start developing on such a thing, and they're actually more further in research and actually building it. I know that this project has been funded by the China government, and it does not include a lot of international cooperations. I'm not sure on anything else about it.
That's absolutely fine. Shaura, you mentioned a little about space policy, that our government should give a push to these projects and things like this. So the platform is all yours. What do you exactly want our government to do, or maybe the international powers to do, and come together and cooperate on the matter?
So I think that, as I said before, a big problem that has held science back throughout the ages, and that has proven to be that again and again, has been that while scientists will go and figure out the science and the theory, the actual power to bring change stays with the policymakers. So to bring such large-scale change, we need to bring those both together and bring some common understanding. So I think that the first step would be for the governments to get more scientists and scientifically educated people involved in their parliaments and in political positions, so that they can have someone who's actually educated on these topics and that understands what a space solar farm really is all about and how it works in their decisions. And I think the first step for that would be that, first and foremost, obviously being someone who's going into science myself, I can't expect the government to just get up and start listening to us scientists. So the first step would be maybe with this UK-China plan that's going on, to provide some demonstrations into how this could be a great big step for the future and how this could actually benefit the nations themselves directly, rather than just giving their funds away to some scientific project that they don't know what merit they'll get from it.
Okay, and do you also think that, you know, the general population of this country, they should be educated about the various feats and the various advancements that our country is making, and, you know, little things out there? Like, for example, when I hear the word space solar farm, I understand that, okay, they are talking about a solar farm probably in space, but of course I need you all to make me understand how it works. So, you know, do you think, how can we educate the general population about these little things that's happening? Because even that makes a difference. We get a sense of pride, we get a sense of motivation, and a sense of, you know, of looking deep into the future, that yes, of, you know, unlocking, as I mentioned in the introduction, the untapped potential the future holds. So how can we do that? Do you have some ideas in mind? Because you all are still very young and you all are going to venture into the field further, and then of course you will have your own ways and ideas to educate people.
So the STEAM department at our school, they try to engage us in conversations about science at a very, very young age, and I think that's a great initiative towards spreading awareness about science. So we have this cross-campus society at our school called Careers, where faculties and students come together to share their best practices, their innovations and their research about science across the globe.
Okay, that's absolutely lovely. But also, guys, doesn't he seem like the Sheldon Cooper? You know, the way he keeps talking about the government and policy, and I will work for science and all of those things. It was lovely talking to you all, and I'm sure you all are going to do great things in science and space, and all the very best. And of course, your school is doing a wonderful job in educating you, and especially bringing so many schools together. That is, I think, one takeaway, my personal takeaway from this interaction, that schools are coming together these days. Okay, thank you so much, guys.
Thank you so much.
Thank you, ma'am. Thank you.
So this was a wonderful conversation with Sarah, Nishtha and Shaurya. Thank you so much.